AP Physics 1 Part 1 tutorial. I did it on Friday, but the sound was completely missing, so I'm doing it again. The first problem has two parts, 1A and 1B. Both have to do with two boxes connected by a rope. The first one has no friction, the second one has friction. A 12 kilogram box sitting on the surface, and then you have 10 kilogram box sitting on the same surface connected by a rope. You pull them by some applied force, 40 Newton at 60 degree. You want to find the tension on this rope. That's the problem. First, assign them box 1 and box 2. Now, free body diagram for M2 would be the weight, which is mg or m2g, 10 times 10, 100 Newton, fx, 40 cosine 60, 20, fy, 40 sine 60, 55 Newton, fn, 100 minus 55, 65 Newton, ft. So that's the free body diagram for box 1. Box 2, box 2, box 1, fg is equal to m1g. So fg is equal to m1 is 12 times 10, 120 Newton. This is your ft, this is your fn. Fn is also 120 Newton. Okay, now Newton's second law over here is very simple. F is equal to ma, m2a. At the x direction, you have fx minus ft is equal to m2a. You have over here Newton's second law, F is equal to ma. At the x direction, m1a, because this is box 1. How many forces at the x direction? Only one, ft is equal to m1a. I'm going to isolate t, fx minus m2a is equal to ft. Notice that I have ft over here, I have ft over here. So I'm going to set them each other. So I'm going to write ft is equal to ft. So this ft is fx minus m2a. Fx minus m2a. This ft is just m1a. So I'm going to write fx is equal to m1a plus m2a. I'm going to isolate a, factor out, giving me m1 plus m2. I'm going to solve it for a, fx m1 plus m2. So acceleration is fx is 20, 12 plus 10, 22. Now this is acceleration. Now I'm going to find ft. Ft is m1, which is 12. Acceleration is 20 divided by 22, which is two significant number, 11 Newton. So this is the problem number 1. Now let's go solve problem number 2, which has to do with, again, two boxes, but this time with friction. So I'm going to write quotient 2. Let's do it over here because we probably need more room. So I have 12 kilogram connected by a rope, and you apply Fp 110 Newton at 60 degree. Hopefully you see my handwriting. Okay, the mu s is 0.4 and mu k is 0.3. What we want to find is the friction on the acceleration on the system. We're going to assign this as m1 and this as m2. We're going to start with m2 as usual. Fg is equal to m2g. M2 is 10 times 10. 10 times g is negative 10 meter per second square. We're going to keep using it. So 10 times 10 is 100. So Fg is 100 Newton. Okay. Fx 110 cosine 60 is, I believe, 55. Fy. 110 sine 60 is 95, I believe. Fn. 100 minus 95 is 5. Fk. 5 times 0.3 is 1.5. Ft. All right, we're done with the first one, M2. This is free body diagram. Now we're going to do M1. Fg is M1g. 12 times 10. Ft. Fn. 120. Ff. 120 times 0.3. Okay, so I have the free body diagram for M2, free body diagram for M1. Okay, so you're going to do Newton's second law. F is equal to ma at the x direction, M2a, all the forces, Fx minus Fx is the 55 minus 1.5 minus Ft is equal to M2a. F is equal to ma, M1a at the x direction, two forces, Ft minus Ff is equal to M1a. So we're going to isolate Ft both sides. We're going to write this one, Ft minus 36. Ft minus 36 is equal to M1a. We're going to write Ft is equal to M1a is equal to 36. This is the second equation. This is the first equation, M1. And then we're going to write that one, 55 minus 1.5 minus Ft is equal to M2a. So you're going to write 55 minus 1.5 minus M2a is equal to Ft. So we're going to set Ft is equal to Ft. So let's write Ft, M1a, Ft is equal to M1a plus 36. M1a plus 36 is equal to Ft is 55 minus 1.5, which is 53.5 minus M2a. Okay, that's it. So we have M1a plus M2a is equal to 53.5 minus 36. So A, M1 plus M2 is equal to 17.5. So A is equal to 17.5 M1 plus M2. So A is equal to 17.5 divided by 12 plus 10, 22. So this is less than 1. Yeah. So 0.899 meter per second. I'm going to write it here. Acceleration is 0.899 meter per second squared. Problem 2. Although problem 2 has 3 parts, they are connected by semi-Sturian, that is inclined plane. The first one has no friction, so it's just g sine theta. The second one has a friction but only one mass. The third one has friction and 2 mass. So the first one has no friction, 1 mass. Second one has 1 mass of friction. The third one has friction and 2 mass. Okay, so the first one is pretty easy. Question 2a. So this is question 2a. So you have an inclined plane and there is a mass sitting over here. Okay, and this is 30 degree. I ask you to find the acceleration. We're going to always, as usual, we're going to start with the free body diagram. And what is this? This is FG. We don't have to draw it. How do we know FG? Because this is not perpendicular. This is FG perpendicular. How do we know? Because this is sitting normal with respect to the box. And this is Fn. We probably don't need it because there is no friction. This is FG parallel. That's all going on. So we're going to use Newton's second law. F is equal to ma at the direction. This is the parallel to the m direction. So this is FG parallel is equal to ma. So FG parallel is mg sine theta is equal to ma. So cancel. Acceleration is g sine theta. So acceleration is g is 10 sine 30. So this is 5 meter per second square. So the problem 2a is 5 meter per second square. Now let's go problem 2b. Problem 2b has to do with one mass, but also friction. Okay, so you have the mass, you have the 30 degree, mu k is 0.3, mu s is 0.4. Free body diagram, I'm going to start with a normal force. So this is F normal, this is FG perpendicular, this is mg cosine theta, this is FF, this is FG parallel. Okay, so we're going to use Newton's second law to do the business. I'm going to write it over here, FG perpendicular. So F is equal to ma at the x direction or at the direction of the ramp is parallel. So we're going to say this is positive. So FG parallel minus FF is equal to ma. So ma is equal to FG parallel. So mg sine theta minus mu k mg cosine theta. As you see that cancel, so you don't need m. So acceleration is g sine theta minus mu k g cosine theta. So theta is 30 degrees, so you're going to replace this by 30. So acceleration is g is 10 sine 30, which is 5, minus mu k is 0.3 times 10 cosine 30. So acceleration is 5 minus 10 times 0.3 is 3 cosine 30 is 2.6. So acceleration is 2.4. Okay, 2b is 2.4 meter per second square. Now let's do 2c. 2c, again, inclined plane, but two boxes connected with a rope, and there are frictions. So there is a pulley, box 1 connected by a rope, box 2, you're going to say 4 kilogram, you're going to say 2 kilogram. So that means acceleration is this way. Okay, so what's going on? As usual, this is m2, this is Fg is equal to m2g is equal to 4 times 10, 40 Newton. This is, there is nothing at the x direction. This is Ft. So Newton's second law tells us F equal to ma at the y direction, all the forces Ft minus m2g is equal to m2a because acceleration is downward. So Ft is equal to, notice that this is negative because this accelerating downward. M2g minus m2a. Okay, so I'm going to go to box number 1. What's going on? I have, I'm going to put it like 30-degree angle. So how do you put it 30-degree angle? This is 30 and then draw the box. Now you erase this. Okay, so this is what we call copy and paste. This is normal. So you're going to say FG perpendicular. This is FN. This is FF. This is F. This is FG. This is FF. This is FG parallel. Okay. So what are you going to do? You're going to use Newton's second law. F is equal to ma at the ramp direction. Okay, which is parallel. Okay. So I have Ft minus Fg parallel minus FF is equal to m1a. Okay, so I'm going to isolate Ft is equal to m1a plus Fg parallel plus FF. Okay, now I'm going to say Ft is equal to Ft. Let's see what happens if I do that. So Ft is equal to Ft. If I do that, what happens? What do we see? M2g minus M2a M1a plus Fg parallel plus FF. Okay, so what I'm going to do, I'm going to isolate this two because I'm looking for acceleration. This one and this one. I'm going to isolate them. So M2g minus Fg parallel minus FF is equal to M1a. I'm going to send this to other side so it's become positive. Okay. So I'm going to factor out a. So M2g minus Fg parallel minus FF is factor out a M1 plus M2. So then I'm going to isolate a or solve it for a M1 plus M2. On the top I have M2g minus Fg parallel minus FF. So acceleration is M2 is 4. 4 times 10 is 40, which is from right here, minus Fg parallel mg sine 30 minus FF mu k mg cosine 30. 2 plus 4. 2 plus 4 is 6. So acceleration is 40. M is 2. 2 times 10 is 20. 20 sine 30, which is 10. 0.1. The mu k is 0.1. Mu k is 0.1 times 0.1 times m is 2. G is 10 cosine 30 divided by 6. So acceleration is 40 minus 10 minus 2 times 10, which is 20. 20 times 0.1, which is 2. 2 cosine 30 is 1.7. Let's say just 2. 6. So acceleration is 40 minus 12 over 6. So acceleration is 28 over 6. 4.7. If I ask for 2 sig fig, then it is 4.7. Probably I asked for 2 sig fig, but I'm not sure. Okay, that takes us to problem number 3. 3A is the vertical jump. Location A, location B, location C. Location A, y is negative 0.3, y is 0, location C, y is 0.9 meters. Location A, velocity is 0, location B, velocity we have to find it, location C, velocity is 0, location A, acceleration is 0, acceleration we have to find it, acceleration is g. You crouch, what does that mean? You crouch 0.3 meters. What does this mean? Max height, right? Your max height is 0.9 meters. Measure from y is equal to 0. I ask you to find, you are standing, if you are standing on a scale, what the scale will read at location B. You are at location B just before you take up the ground. Okay, so now first thing we're gonna find VF square is equal to VI square plus 2AD. We're gonna say this VC square is equal to VB square plus 2. Since we are using between B to C is free fall because you are take off the ground at B, so you are on free fall. So it's G and D is H. This is 0 is equal to VB square minus 20.9. So VB square is equal to 18. Okay, great. Now, well, we can do better. B is square root of 18. So VB is square root of 16 is square root of 16 is 4. So it's 4.4, I believe. 4.3. Okay. All right. So now we're gonna do VF square is equal to VI square plus 2AD. This one would be VB square, and this one is VBA square plus 2A, and this is crouch height. Crouch height is 0.3 meters. Now we are doing A to B. B is square root of 18 square is equal to VA is 0 plus 2A, and this is 0.3. So 18 is equal to 0.6A. So A is equal to 18 over 0.6. So A is equal to 30. So 4.3 and 30. 30 and 4.3. Okay. All right. We don't even need velocity. All we need is acceleration, and acceleration is 30. Okay. So great. Now what are we going to do? I'm going to draw the free body diagram at location B. At location B, you have FG, which is mg, which is the person is 80 kilogram, 80, g is 10, so is 800 Newton. This is Fn, the person is accelerating from B to C. So F is equal to ma. At the y direction, all the forces are Fn minus mg is equal to ma. So Fn, the scale will read mg plus a. So scale will read m is 80, g is 10, a is 30. So scale will read 80 times 40, 3200. If I ask for 2 sig fig, then it's going to be 3.2 times 10 raised to 3 Newton. This is what is scale going to read. Problem number 3b, I ask you, when you are taking up the ground, you are pushing the ground, right? You are pushing the ground with 3200 Newton, right? How much net force going to acting on the ground? Let's find. The net force acting on the ground is F is equal to ma. So F is equal to m is 80 and this is 30 acceleration. So F is equal to 2400 Newton. If you don't see that, then we can do free body diagram. We can use free body diagram to make it obvious. We can say F is equal to ma at the y direction, and then we can say F is equal to F net, all the forces. That's what we're trying to find. So Fn minus Fg is equal to F net. So F net is equal to Fn minus Fg. What is Fn? Fn is 3200. What is Fg? 800. So that also give you 2400, because 3200 minus 800 is 2400. This is Mr. Bari. I'm going to use the color coding. This is Fg. What does that mean? Force on body by earth, which is 800 Newton. So now we're going to call it action. Now how can we draw the reaction? Newton force sphere, Newton third law for sphere. Okay, so we're going to draw it over here on the earth. So no, I want to use the same color, the red. So you're going to say Fg prime or F on earth by body, which is 800 Newton. I don't want to do it here. It's getting crowded over there. So Fg prime F on earth by body, which is equal in magnitude but opposite in direction. We're going to call it reaction. So action, reaction. Action causes the reaction. This is going to be in quiz number 6 and exam number 6. I'm going to give you the same problem and I'm going to ask you to draw the Newton force sphere. What else? We have we're going to call F push or F on body by earth, which is 3200 Newton. Where is the Newton force sphere? You don't have to align it. It's the direction is important, not the location. So F push prime or F on earth by body, which is 32 Newton. Understand that the net force on body is this too. 3200 minus 800. So net force on body 2400. Net force on earth 800 minus 3200, negative 2400. You have to write this negative, otherwise of course you're going to lose point. That's the whole point. But the quiz number 6, you have to draw this, fully understand the Newton third law, force pair. Okay, that takes us to problem 4. Problem 4a. We're gonna call it the counterweight. Let's say counterweight is 3000 kilogram. That's M2, and then let's say weight is 1000 kilogram, or elevator is 1000 kilogram. You're gonna call M1. We're gonna find the acceleration in the system. This is M2. This is M1. M2. You see only two forces acting on it. This is Fg, M2g, and this is tension force. And over here, also two forces are acting on it. This is Fg is equal to M1g. This is Ft. Newton's second law tells us F equal to ma at the y direction, and this has to be m2a, and acceleration is this direction, so we're gonna put negative, gonna put 2. How many forces? Ft minus Fg equal to negative m2a. Right, let me see this one. F equal to ma at the y direction, m2a. This is accelerating this direction, so this is positive. Two forces, Ft minus m1g is equal to m2a. So Ft is equal to m1g plus m2a. Ft is equal to m2g minus m2a. So you're going to write Ft is equal to Ft. So m1g plus m2a is equal to m2g minus m2a. So I'm going to bring this one over here, m2a. Wait a minute. This is supposed to be m1, because this is m1. This is m1. This is m1. So m1g plus m1a. Okay. So what are you going to write? m1a plus m2a is equal to m2g minus m1g. We're going to factor out a, m1 plus m2. We're going to factor out g, m2 minus m1. Acceleration is m1 plus m2, g, m2 minus m1. Acceleration is m1 plus m2, which should be 4000. G is 10. M2, which is 3000. 3000 minus 1000, which is 2000. So acceleration is 20,000 over 4,000. 0, 0, 0, 0, 0, 0. 4 goes to 25 times. So acceleration of the system is 5 meters per second square. So that's the answer. Now let's go B. B, the wording was not good, so I fixed the wording. So the B, you're not gonna I'm not gonna grade the 4B because everybody gonna get 4B right. The wording was not clear enough. So this is how I'm gonna change the wording next on quiz number 6. I'm gonna say this is counterweight, which is 3000. I'm gonna have this is elevator. Elevator is 1000 kg. This is elevator. John is 100 kg. John is in the elevator. Scale is 10 kg or 1 kg, let's say, not 10. This is the scale. John is standing on the scale. So all together 1110 kg is the elevator, and the counterweight is, so M2 is 3000, M1 is 1110. Okay. So this is exactly how I'm going to word it for quiz number 6. So I'm giving you a few days notice. M2 is FG is M2G, this is FT. So this is FT minus M2G is equal to minus M2A. This is M1, this is M1G, this is FT. So FT minus M1G is equal to M1A. So FT is equal to M1A plus M1G. FT is equal to M2G minus M2A. So again FT is equal to FT. So M1A plus M1G is equal to M2G minus M2A. We're going to bring all the A to this side. M1A plus M2A is equal to M2G minus M1G. A M1 plus M2, G M2 minus M1. So acceleration is M1 plus M2. On the top you have G M2 minus M1. Acceleration is 10. M2 is 3000 minus 1110. 3000 plus 1110. 1110. Acceleration is 10 1890. This is 4110. So acceleration is 18900 and 4110. 0 cancel. Acceleration is 1890, 411, 4.6. Now we're going to draw the free body diagram on the mass of Mr. Body. So this is FG, which is 100 times, so 1000. This is Fn. So Fn is equal to mg plus a. So Fn is equal to me is 100, 10 plus 4.6. So Fn is equal to 100. Let's say 50. Okay, 14.6. Fn is 1460 Newton. So the scale will read 1460 Newton, or scale will read 146 kilogram. Both of them are valid. Next problem is problem 5. 5a, 5b. 5a, 5b, both of them has to do with a box is sitting and you pulling angle theta. There is a friction, but 5b is more challenging than 5a. 5b is actually similar to problem number 8. But let's go over 5a first. Sitting on a table that has some friction 0.2. I have to write it this side. Mu k is 0.2. You pull the box with 60 Newton at 45 degree. You want to find out the acceleration. So let's start with free body diagram. Fg is 12 times 10, 120 Newton. Fx is 60 cosine 45, which is 60 square root of 2 over 2, which is 30 square root of 2, which is 42. So then Fy must be also 42. Fn 120 minus 42, 78. Ff 78 times 0.2, which is 16, more or less 16, let's say. So F is equal to ma. We're gonna write at x direction all the forces. I see Fx, I see Ff, which is ma. So ma is equal to Fx minus Ff. All right, so ma is equal to Fx 42 minus 16. So this is 42 minus 16. This is 4, 20, 24, 26. So this is 26. So acceleration is 26. Our mass is 12, 2.2 meter per second square. So 5a is easy. 5b is a little bit challenging. So please pay attention, because 5b is going to be in quiz number 6 and also exam number 6 on Wednesday and Friday. 5b. All right, so 12 kilogram object sitting on a surface which has a friction 0.2. You apply same force, 60 Newton, but the problem is I did not give you theta. You're going to have to find whose theta will maximize the acceleration. Now, if there was no friction, then of course it's 0 degree. If, for example, there is no friction, then this angle, as angle approaches to 0 degree, right, you have a maximum acceleration, right, of course. But this is not case here. There is a fight between, hopefully you realize that, because I'm going to make it a little bit tricky on quiz 6 and exam 6. So small angle give big fx, big angle, small angle give big fx. However, small angle give big fn, big fn give big ff. Okay, big angle give small fx. However, big angle gives small fn, which gives small f. So is small angle good or big angle good? Neither. So you have to find, you have to do trade-off, and optimization allow you to trade off. And the way to go is dot product. Okay. So you're going to start with the free body diagram. (12 times 10 is 120. You're going to call it weight. 60 cosine theta. We're going to call it fx. 60 cosine theta. Fy. 60 sine theta. Fn. We're going to call it 120 minus 60 sine theta. We're going to call this one ff. Mu k, which is 0.2, is 12 sine theta. Okay, so this is our free body diagram. Great. You're going to write Newton's second law. F net is equal to fx minus ff. So F net is equal to fx is 60 cosine theta minus 24 plus 12 sine theta. Okay. Now you're gonna have to write acceleration is f net over m. So acceleration 60 cosine theta minus 24 plus 12 sine theta divided by 12. So acceleration is 5 cosine theta minus 2 plus sine theta. Now we're gonna write acceleration in terms of angle. Acceleration with respect to the angle. Which angle give you the biggest acceleration? That's what we are finding. So you're going to rewrite 5 cosine theta plus sine theta minus 2. Let's understand these three terms, right? I'm gonna, as I said many times, I'm gonna test you on this idea on Wednesday quiz 6, Friday exam 6. This, I'm going to ask you to rewrite this 5 cosine theta. What does that mean? 5 cosine theta is, if you take a look at the free body diagram, this can be written as t cosine theta. So t cosine theta, and that can be written as mg, right? So this is what's going on here. This is that. What about the sine theta? The sine theta is, if you look over here, that's your sine theta. Okay. If you take a look at the minus 2, or the minus 2 compound, minus 2, if you can rewrite this one, mu k mg, right? Mu k fn is mg. So mu k mg, and that is minus fy. So what is ff? Ff is, you have 24. So ff is, let me rewrite that. Ff is mu k fn. Mu k, which is 0.2. Fn is 120 minus 60 sine theta So 120 is mg. So this one is mu k mg over m. So mm cancel. So mu kg. So this one you cannot change now. Irreducible. This one is irreducible. Even if you make your theta big or small, theta, no theta, this one will never be able to change. This -2 is the vertical shift down. It comes from mu k friction and the acceleration due to gravity, which you cannot remove. So theta has no effect on this. You cannot optimize this. You cannot make it anything else, but it's going to remain -2. So you cannot optimize -2. -2 is going to be there in for this problem. Okay. So theta is equal to 5 cosine theta plus sine theta. Okay. Okay, great. Now 5 cosine theta sine theta, I already explained. This one has to do with this one has to do with that. Good. Now we're gonna have to use the dot product. R cosine theta minus phi is equal to A cosine theta plus B sine theta. So this can be written as A cosine theta plus B sine theta. Okay. A is 5 and B is 1. R is equal to A square plus B square. What does that mean? R is equal to 5 square plus 1 square, which is square root of 26. So you can write square root of 26 cosine theta minus phi. Okay. So now it's time to find to make a connection with u dot v. All right, so this is the dot product. Okay, so u is 5 1 and v is cosine theta sine theta. Okay, so you have 5 cosine theta plus 1 sine theta. Okay, now you see the connection. Hopefully you do, right? Okay. Now, what is uv doing over here? U is a vector and v is a vector. And the angle between u and v is, let's say, alpha. Okay. Now, what we're going to do over here is we're going to see the phi. So the phi is okay, so we're going to write tangent theta. We can also write this way. Let's see which way you can write. We can say that 5 we can say that the tangent theta is equal to y over x. So theta is equal to tangent inverse tangent y over x. So which is y 1 over x 5. So theta is 11. Okay, now the critical thing over here we have to understand, so we're going to rewrite this statement. The square root of 26 cosine theta minus 11. So I'm going to drop 26, the square root of 26. Why is that? Because square root of 26 has nothing to do with maximizing, right? I want to maximize the angle who is going to give me the maximum acceleration, and that is can be accomplished when cosine theta minus 11 is equal to 1. Why is that? Recall, cosine theta is between -1 to 1. Cosine can never be more than 1. That's just fact. The trigonometry fact. One of the trigonometry fact is cosine can never be more than -1, and it can never be less than -1. So, for example, I don't know. Let's say what is cosine 1? The cosine 1 in the unit circle at 0 degree you get 1. When cosine is 0 degree you get 1. So 0 degree give you the maximum value of cosine. Okay, so you want to find what angle gonna give us the maximum acceleration, and that is, we know for sure 1, and that is 0 degree. So that's why we wrote 1. Good. So now acceleration theta is equal to theta minus 11 is equal to arc cosine 1. So theta minus 11 is equal to 0. So theta is equal to 11. So at 11 degree, you get the maximum acceleration. Now you're going to go and try to see that is the case. So we're going to see 11 degree going to give us the maximum acceleration. So you're going to come over here. We're going to write 11 degree is 5 cosine 11 plus sine 11 minus 2, and indeed this is going to give us 3.1 meter per second square. So we almost done 6, 7 and 8. So problem 6 has to do with 2 boxes on top of each other. Problem 7 is also 2 boxes. Problem 8 is again dot product 3 kilogram. This is M1. This is M2. This is M1, 8 kilogram. Okay. Friction is 0.3. Friction is 0.15. We want to find the maximum applied force will not slip box 2. Okay, so the maximum applied force, applied force max, that will allow box 2 to keep moving with box 1. A little bit more than that, the box 2 will slip off from the top of box 1. That's the problem. Okay, now M2, so you're going to put M2 over here. Let's do the free body diagram over here. So M2, so I have M2G, I have FS. This is, by the way, this is mu S. It has to be mu S. This is mu K, because this box is not moving. Box 1, try to keep the box 2 with the box 1. So we're going to say that on box 2 by 1, right? Okay, on box 2 by 1. Okay, this is static friction, and that is Fn. Fn is how much? M2 is 3 times 10, 30. So this is 30 Newton. Okay, so this is M2. So what's going on? What does Newton law tell us? As F equal to ma at the x direction, M2a. So only one forces. We're going to call mu. This is Fs. So Fs is equal to M2a. Fs can be written as mu s Fn. M2a. Mu s can be written mu as M2g is equal to M2a. M2 cancel. A is mu s g. So A is mu s is 0.3, G is 10. So acceleration is 3. Okay, so that this box is accelerating 3 meter per second squared. More than that, the box number 2 will slip off from box 1. Okay, so now we're going to do box 1. This is M2G, and that is 30 Newton. This is M1G or FG, that is 80 Newton. This is F normal 30 plus 80, 110 Newton. This is F applied. This is Fs from, this is on 2 by 1, so this is on 1 by 2. This is equal in magnitude, opposite in direction, and that is how much friction. So let's find the friction over here. Mu s Fn, mu s is 0.3, Fn is 30, so it's 9. So you're gonna write 9. So Newton's second law tells us F is equal to ma, m1a positive because moving to the east at the x direction, all the forces Fa minus, there is another force Fk. This is mu k Fn. Mu k is 0.15, Fn is 110, so this is 16.5. So Fa minus Fs minus Fk is equal to m1a. We want to find out maximum Fa will allow box 2 sitting on box 1. Fs plus Fk plus m1a. Fs is, we found it, 9 plus Fk is 16.5 plus m1 is 8 times acceleration 24. So Fa is 9 plus 24 is 23. 23 plus 17 is 50. So we're just going to see 49 point. This is remember 16.5. So this is 16.5. This is 49.5. Or 50, doesn't really matter. Oh yeah, it does matter. 49.5. So 50 Newton, this box will slip off. So 49.5 is the maximum. Let's go to the next problem, which is easy. Also still has to do with 2 boxes. 7. 2 boxes. This is pulley. This is box 1, 3 kilogram. This is box 2, 7 kilogram. Friction 0.2. Yeah, that's it. We're going to find the acceleration. M2 Fg is equal to M2G, which is equal to 70. Ft. So Newton's second law tells us Ft minus 70 is equal to negative M2A. So this is M1. This is Ft. This is Fg is M1G, which is 30 Newton. This is Fn is 30 Newton. This is Fk. So mu k, Fn, so mu k is 0.1 times 30, which is 3. So Fk is 3 Newton. Okay, so now Newton's second law tells us Ft minus 3 is equal to m1a. So Ft is m1a plus 3. ft is 70 minus m2a. So you're going to say ft is equal to ft 70 minus m2a is equal to m1a plus 3. So you're going to say 70 minus 3 is equal to m1a plus m2a. So acceleration m1 plus m2 is equal to 67. A is equal to 67 m1 plus m2. A is equal to 67, m1 is 3, m2 is 7. 67 divided by 10. So A is 6.7 meter per second square. That takes us to problem number 8, last problem, part 1. Okay, so 10 kilogram box, two forces acting on it at time 0. Two forces acting on it, A is 50, B is 70. What theta will allow them to get t is equal to 3 seconds, d is equal to let's say 4 meters. What angle will allow at t is equal to 3 seconds the displacement 4 meters? Okay, again, this is a optimization problem. This is not similar to the 5b, but we're gonna use the dot product. This is fixed, acceleration is fixed. You don't have to maximize the acceleration. Okay, so let's do it. Ax is 50, Ay is 0, Bx is 70 cosine theta, By is 70 sine theta. This is Fg is equal to 100 Newton. This is Fx is equal to 50 plus 70 cosine theta. This is Fy is equal to 70 sine theta. This is Fn is equal to 100 minus 70 sine theta. This is Ff is equal to mu, I believe I give you a mu k. This is 0.2. Is that 0.2? Mu k 0.2, right? So mu k is 0.2. So you're going to have 0.2 times 100, so 20 minus 0.2 times 70, 14 sine theta. Okay, so this is our step 1. This is our step 2. Let's see, this is our step 3. F net is equal to Fx minus Ff. Fx minus Ff. Fx is 50 plus 70 cosine theta minus 20 plus 14 sine theta. 70 cosine theta plus 14 sine theta plus 30. This is our F net. So our acceleration is 70 cosine theta plus 14 sine theta plus 30 divided by 10. This is step still step 4. Step 3. 7 cosine theta plus 1.4 sine theta plus 3. This is our acceleration. Step 4. D is equal to half a t square. D is equal to half a at time 3. Acceleration d is 4, right? We don't have to put that. D is equal to 4.5 a. Step 5. 4.5 a is equal to 7 cosine theta plus 1.4 sine theta plus 3. We're gonna distribute this. 7 times 7 times 4.5, 31.5 cosine theta plus 1.4 times 4.5, 6.3 sine theta plus 4.5 times 3, 13.5 is equal to of course 4. Okay, so 31.5 plus 6.3 sine theta is equal to 4 minus 13.5 negative 9.5. Divide everything by 6.3. So you have 5 cosine theta, cosine theta plus sine theta is equal to 9.5 divided by 6.3, 1.5. Okay, now step 6 is add cosine theta minus p. So r is the square root of 26 cosine theta minus p. Tangent theta is 1 over 5, right? You see that 5 sine. So 1 over 5. So theta is tangent inverse 1 over 5, which is 11. Okay, so you're going to say 26 cosine theta minus 11 is equal to negative 1.5. So cosine theta minus 11 is equal to negative 1.5 square root of 26 inverse cosine. So inverse cosine negative 1.5 divided by square root of 26, and that is 1.7. So theta minus 11 is equal to 107. So theta is equal to 107 plus 11. So theta is equal to 119. Yeah, 119 degree angle gonna make it possible over here. So this must be 119 degree. So that at 3 seconds the displacement is 4 meters. So we're done with part 1. Now we're gonna do part 2. So part 2 is gonna take I don't know how long it's gonna take. There are 20 problems. Hopefully it's gonna take 20 minutes. 20 problems, and I'm gonna see I can do it in 20 minutes. First problem is very easy. You move 24 meter east, right, and then you turn around. You use cardinal direction, which is north and west. So you move 35 degree northwest. So 35 degree northwest. Okay, and then this is 35 degree northwest, and you move 36 meter. And then this is 24 meter. You draw 24 meter again, and then you draw this one again, and this is 145 degree. I'm going to draw it to the scale on the paper, so then you're going to understand it better. So this is 145, this is 145, this is 35. Okay, so this is the result, and I'm going to use the red color if I do have red color. I don't. Okay, so this is a little bit more than 90 degree. So this is a little bit more than 90 degree. Okay, so 90 degree would be this, and this is a little bit more than 90 degree, but this is the resultant, and resultant is r squared is equal to a square plus b square plus 2ab cosine 145, because the law of parallelogram takes the angle between the two vectors, the tail and tail, or head and head. So r squared is equal to a squared is 24 square plus b squared is 36 square plus 2a 24, b is 36 cosine 145. So r is 21. So the size of this one is 21. Let's do it on the paper. Let's see. So 12 meter is 1 centimeter. Then I have to do, this is 2 centimeter. 2 centimeter is 24. So this is 24 meter. 2 centimeter is 24 meter. Okay, so 12 meter is 1 centimeter. Okay, now I'm going to have to make 35 degrees. This is between 40 to 30, 35. All right, so now 36 meter, what is our convention? Our convention is meter centimeter. So 36, what is it? 1 centimeter is 12 meter. This cancel. 12 goes to 36, 3 times 1. Okay, 3 times 1 is 3 centimeters. So we have to go 3 centimeters. This is 3. Okay, so we are going 3 centimeters. Okay, so this is 145 degree. Why this is 145 degree? Because 145 plus 35 is 180. Okay, so this is 145. So we have to have 145 here. This is 145 is right here. Okay, so this is only, we're gonna go only 3 centimeters. Okay, so great. Now we're gonna do this one. This one is hopefully only 2 centimeter, because that has to be 24. So this is 2 centimeter, and it is yeah, I'm trying to draw it to the scale, but it's very difficult to draw it to the scale, but hopefully it is. Okay, now this is a parallelogram. This is the nice parallelogram. Now we're gonna draw the resultant vector. So the resultant vector, this is 90 degree, by the way. This is 145. So this is 145. I'm gonna write 145 here. So this is 35 degree. This is 145. This is 145. This is 35. And I'm gonna draw the resultant by red. So this is resultant. This is resultant. 2 centimeters. So this is 1.8 centimeter. So 1.8 centimeter. So 1.8 centimeter times, here is centimeter, here is meter. So we have 1 centimeter is 12 meter. 1 centimeter is 12 meter. So centimeter cancel. 12 times 1.8. So 12 times 1.8. That is exactly 21. Very nice. 21 meter. And the r square is equal to a square plus b square plus 2ab cosine 145 is r square is equal to 24 square plus 36 square plus 2, 24, 36. Cosine 145 is going to give you exactly same thing. You're going to go to the calculator, you're going to write 24 square and then plus 36 square plus 2 times 24 times um, 36 cosine 145, and that's exactly gives you 20. So let's go over problem number 2. Problem number 2 is so let's go over problem number 2. Problem number 2 is very easy. Problem 2, you have you are on the tall of a building, and again height h. This height is given 30 meter. This is ball A and this is ball B. The ball A and ball B, they both hit with same velocity v, right? So you drop a ball with initial velocity. You throw a ball with initial velocity 20 meter per second at 90 degree. So you throw it like this, 20 meter per second. Since VA has to be equal to VB, finding this one will allow you to find the height. So VA square is equal to VI square plus 280. So VA square is equal to VI square. What is it? 20. So 400 plus 2 times 10. G is 10. Negative 10. 2 times 10. 2 times negative 10. Negative 20. Negative 20 times negative 30. So 600. So VA square is equal to 1000. So since you are saying that this initial velocity is 0 because you're dropping it, since you're saying VA is equal to VB, you are basically saying VA square is equal to VB square. They're the same thing. So VB square is equal to VI square plus 2AD, right? So VB is equal to VA. So then you can say 1000 is equal to VA is 0 because you're dropping it. Plus 2 times negative 10, which is negative 20, H. So 20H. So H is equal to 0, 0 cancel, 50. So the height is 50 over here. So let's go problem number 3. The problem 3 is very very simple problem. I gave you, well, it's kind of interesting problem. Why? Because a 1200 kilogram car, right, is moving for 16 seconds. The first 4 seconds is speeding up. The second 4 seconds is moving with constant velocity. Then from 8 to 12 seconds is slowing down, and 12 to 16 seconds is at rest. So you see Newton second law in the beginning for 4 seconds, and then you see Newton first law from 4 to 8 seconds, and 8 to 12 seconds you see Newton second law again, and 12 to 16 seconds you see Newton first law. So it's a roller coaster journey of Newton first law and second law using kinematics, using force to explain kinematics. Let's draw it. Let's draw the graph. This is D, this is 2, 4. So you're gonna draw the line. Okay, so now what I'm gonna do, we're gonna create a table from this. So I'm gonna create the table over here, so it's gonna be better. So the time 0, 2, 4, 6, 8, 10, 12, 14, and 16. This is D, this is B, this is A, this is Newton's law. Okay, so at 0 second, of course, is 0. I'm going to use the red color. At 2 seconds, 4. At 4 second is let's say 16. At 6 second, 32. At 8 second, 48. At 10 second, 60. At 12 seconds, 64. 14 seconds, 64. And 16 seconds, 64. Looking at the graph, what I notice is that from 0 to 4 seconds is speeding up. Speeding up, as you see, 0 to 4 seconds is speeding up. What does that mean? Here velocity is 0. Okay. Here velocity is not 0. Here velocity is not 0. So it's speeding up. So we have to find the acceleration. Let's find the acceleration at 4. So d is equal to half at square vit plus half at square at 4. At 4, this is 16. 16 is equal to 0. Vi is 0, of course. Why Vi is 0? Initial velocity is 0. Half a we are trying to find at t at 4. 4 is square. So 16 is equal to half a 16. So 16 is equal to 8a. So a is equal to 2. So acceleration is 2 here, 2 here, 2 here. Great. So acceleration from here to here is 2. So is it speeding up? Okay. So I'm going to make it green. So this is speeding up. Okay, great. So velocity is at. So 2 times 0 is 0. 2 times 2 is 4. 2 times 4 is 8. Okay. 2 times 0 is 0. 2 times 2 is 4. 2 times 4 is 8. Great. Now, 16 to 32. What is the change in displacement? 16. 32 to 48. What is the change in displacement? 16. So there is no change. What does that mean? Constant velocity. So you're going to write 8. You want to write 8. So acceleration is 0 there. So see how fast you can do it. Acceleration is absolutely 0 over there. Okay, great. So all right, great. So 48 to 60, what do you notice? 12. 60 to so you want to write constant. From here to here is constant. constant means acceleration is 0 and velocity is same, doesn't change. Now from 8 to 12 you see, let's see, what do we see? This is 48 to 60 is 12, the change in displacement is 12. From 10 seconds to 12 seconds, change in displacement is 4. So this is definitely slowing down. Okay. So from 64, 64, 64, so this velocity must be 0, right? Velocity doesn't change, so displacement doesn't change. Okay. So if Vi is 8 and Vf is 0, right? Vf divided by 2. So Vi is 8 and Vf is 0 divided by 2. So who is this 4? So velocity is 4 over here. Okay. So with the velocity 4, we can find the acceleration. How? Okay. So we're going to say that Vi is 8, Ti is Ti is 8. Vi is 8, Ti is 8. 8. Vf is 0 and Tf is 12. So Vf minus Vi delta T. So Vf is how much? 0 minus Vf is 0 minus 8 divided by 4. So this is minus 2. So acceleration is minus 2 over here, minus 2 over here, 0 over here, 0 over here. So this is Newton second law. This is Newton's second law. This is Newton's second law. This is Newton's first law. This is Newton's first law. This is Newton's second law. This is Newton's second law. This is Newton's first law. This is Newton's first law. Now, I want you to see the geometry of this one. The geometry of this one would be so I'm going to color code it. So this is velocity versus time graph. So this is green. So I'm going to do the green. Speeding up. This is constant velocity from 4 seconds to 8 seconds. This is 8. From 4 to 8 seconds is constant velocity. So constant velocity. And 8 seconds to 12 seconds is slowing down. So it's slowing down. And 12 seconds to 16 seconds is at rest. So you're going to come over here. This is 8. You're going to come over here. This is 4. This is 8. This is 12. And this is 16. This is the 16-second motion of the car, Mr. Barry's car. So from here to here, the net force is F is equal to ma. So the car is 1200 kilogram, right? Mass. So the net force has to be F net is 1200 times 2. So 2400 Newton. So from here to here, the net force is 2.4 times 10 raised to 3 Newton. From 4 to 8, the net force is 0. F net is 0. From 8 to 12, right? 8 to 12, F net is negative 2.4 times 10 raised to 3. Then from 12 to 16, the net force is again 0. So you see that how the kinematics really connect with how we can do how we can use the force to explain the kinematics. So this is completely a kinematics, and we use the force to explain the kinematics. So if there is a force, then there is an increase of velocity. If there is no force, what happened? The constant velocity. If there is a force, of course, opposite to the direction of the velocity, okay, then there would be acceleration which is opposite to the direction of the velocity. Then of course the velocity gonna go to 0, and then velocity gonna go to the 0. And then there is, if there is no net force is 0, object at rest, stay at rest. Net force is 0, object at rest, stay at rest. Newton's first law. Net force is negative, so object is slowing down. So this is Newton's second law. Net force is 0, so object moving with constant velocity, 8 meters per second, Newton's first law. Object is speeding up, Newton's second law. This is a wonderful way to understand Newton's first law, second law. Problem 4 is one line. So you have 120 Newton object. You apply 60 Newton. As a result, you apply 60 Newton to 120 Newton object. If you don't like 120 Newton, you're always more than welcome to write the mass. So you can definitely write divide by 10. So you can write 12 kilogram. No problem. Same thing. Okay. So now, as a result of you applying 60 Newton, the object is moving with constant velocity. Constant velocity means acceleration is 0. What does that mean? Where the acceleration 0 come from? That has to be equal in magnitude, opposite in direction. Okay. Therefore, it is moving with constant velocity because the acceleration is 0 and force of friction is 60. Okay, so we have to find the mu k. So Fg is 120 Newton, so Fn has to be 120 Newton. Okay, now Ff is mu k Fn. So mu k is Ff over Fn. So Ff is of course 60 and this is 120. So this is mu k is 0.5 and there is no SI unit to mu k, and that is problem number 4. Let's go problem 5. Problem 5, last time you explored that if okay, so let's say mg is equal to g big M small m over r square. Where this come from? Fg is equal to Fg. Now if g has to go up, m has to go up. If g has to go up, r has to go down. Why? Because this is inverse square law. This is our hypothesis. To make the long story short, g bigger, r is smaller. M cancel. G is 1 over r square. G and m, we're not going to touch them. This time I didn't ask you to touch them. Keep them same. So you're going to say G old, G new, R old, R new. G old is 9.8. We are using magnitude, or even if you don't use magnitude, minus cancel. 10. R old 6370000 square, and R new we're going to try to find out. So you're going to cross multiply. If we do cross multiply, 9.8 6370000 square is equal to 10 Rn. R new. So 9.8 times 4 times 10 raised to 13. Square of this one is 4 times 10 raised to 13, 10 Rn. So this is 4 times 10 raised to 14 is equal to 10 Rn. So Rn is equal to 4 times 10 raised to 14 divided by 10. So R new is 4 times 10 raised to 14 minus 1. So Rn is equal to 4. This is a square. This is a square. This is a square. This is a square. This is square times 10 raised to 13. So then you square it. So Rn is equal to 630 meters. So this is finally Rn is 6.3 times 10 raised to 1, 2, 3, 4, 5, 6 meters. So 6300000 is less than 6370000. So 1, 2, 3, 4, 5, 6, 7. 1 2 3 4 5 6 7. Yeah, right. So our hypothesis is correct. 15 kilogram object, 100 Newton net applied force. I should write applied force. And then force of friction is 50 Newton. Okay, so what we need to know is the acceleration. So F is equal to ma. At the x direction, all the forces Fa minus Ff is equal to ma. So ma is equal to, or we just say ma is the, ma is the Fa minus Ff. So ma is Fa is 100 minus 50. Acceleration is 50 divided by 15. This is 3.3 meter per second square. Problem number 7 is a little bit more interesting than this one. A 10 kilogram box is sitting, right? And there is a friction. Mu s is 0.5, mu k is 0.3. You know that force of friction, mu ffs, ffk. Ffs is mu s fn, mu k fn. So mg is 10 times 10, 100 Newton. So Fn must be 100 Newton. Some applied force over here, okay, from 0 to 80 Newton. All right, that means you keep pulling, starting from 0. When applied force is 0, force of friction is 0 by definition, okay. So mu s is 0.5, Fn is 100, so this is 50. Mu k is 0.3, Fn is 100, so this is 30. So friction graph gonna look like this. So this is 50, this is 30. So this is Fa. What is the minimum Fa that will move the box, right? 0 will not move the box. 10, 20, 30 will not move the box. 40 will not move the box. 45 will not move the box. 49 will not move the box. 49.99 will not move the box. 50 is the Fs max. So anything more than 50, like 50.0001 will move the box. Okay, so 50, you want to write 50. Okay, excellent. So this is what I asked you to do. This is 80. So mu k Fn, this is 30. This is 30. Mu s Fn, okay, which is 0 to 50. So I have to fix it over here. Okay, so this one is less than or equal to 50. It could be 0, it could be 30, it could be 49, it could be 49.9999, 49.9999, it could be 50, but it never can be more than 50. If it is little bit more than 50, it drops to 30. So this is Newton's second law. This is Newton's first law. This is object at rest. This is object is accelerating. Okay, so that's problem number 7. Let's go to problem 8. Problem 8, I give you a box M. You apply force 40 Newton at 60 degree. That's scenario 1. Scenario 2, you mass M, you apply same force. However, your angle is half. So your angle become 30 degree. Fa is same. Angle become 30 degree. If you decrease the angle, acceleration go up. If angle go down, acceleration go up. If angle go down by double, right? If angle 60 degree to if angle go down by half, then acceleration go up by 2, almost 2. So half the angle we can say, or almost 2a, almost, we don't know. Let's see, let's find out. So the first case scenario, let's see over here, scenario 1, fx is 40 cosine 60. So fx is 20 Newton. So let's say m is just 1 kilogram. So acceleration is 20 divided by 1, so 20 meter per second square. All right, same thing, 1 kilogram. All right, so fx is 40 cosine 30. So fx is 35. So acceleration is fx over m. Acceleration is 35 divided by 1. So acceleration is 35. Okay, now you have 35 divided by 20, which is 1.7. So it's 1 times 7, 1.7 times bigger, or we can say almost 2 times bigger. Almost 2 times bigger. If the angle go down by half, acceleration go up by 2. Okay, that's problem number 8. Problem number 9 is vector. So if you have an x-axis, if you have vector A, which is, I don't know, about 30, I don't know what degree angle, I'm not going to make any comment. Let's do it on the, I'm going to have to use the protractor to do this one. So let's use the protractor. For a resultant, this is our A, we're going to draw B. So to draw the B, we're going to just connect the head of A and the head of resultant. So this is B, and B is 2 centimeters, right? B is 2 centimeters. Now what is A? 2.7 centimeter, 2.7 centimeter. Okay, so now let's see the angle. The angle is right here. So this angle is, it shows 70. So this is 70 degree. Okay, so now I have to draw, if this is 2 centimeter, which it is, this one is 2 centimeter, I have to draw this 2 centimeter over here. But to draw 2 centimeter, I have to have, this is 70, so this has to be 110. Why? 70 plus 110 is 180. So I have to draw a dot, one dot, another dot that will allow me to draw a line which is 2 centimeter. So now 110. So now I have to do 2 centimeter. So this is 2. This is B, this is B prime. So now we're going to connect this one, so we're going to call them A prime, and that has to be, A prime has to be 2.7. hopefully it is 2.7. yeah, it is. So this is 110, this is 110, this is 70, this is 70. So we are done. So we now going to measure this one, the resultant. This is the resultant from here to here. This is the resultant. The resultant is 2.5. so this is 2.5 what, centimeter, or unit, let's call it unit. Now A square, which is 2.7, plus B square, which is 2 square, plus 2 times A times B times cosine 110, and that is shows 2.7. maybe I made a mistake. Let's see, let's do it again. It's actually 2.7. yeah, it's actually 2.7. This is 2.5. 2.7 is exactly 2.7. is exactly 2.7. If you bring the camera close, you're going to see this is not 2.5. I measured it wrong. So this is 2.7. So the math fixed the measurement. Well, a little bit off, 2.756, but this is close call. So I'm crouching like this to jump up. This is vertical jumping, right? To do the vertical jump, I have to crouch. Crouch is going to allow me to accelerate. Acceleration going to allow me to have some initial velocity. Initial velocity going to create some displacement. So I'm going to push, all right, during the crouching, I'm going to bend my knee. When I bend my knee, as I move up, right, I push the ground. So the ground going to push me. So I'm going to have some force. At that force, going to give the acceleration. That acceleration going to give the velocity. That's velocity going to give the displacement. Okay, so this is location A, this is location B, this is location C, right? So I'm going to bending my knee, right? So this is y is equal to negative 0.2. This is y equal to 0. I'm going to measure the height from this location. This is y is equal to 0.8. So my vertical jump, right, max height, at max height, this is 0.8 meters, right? This is 0 meter, this is, okay. So how much I crouch? I crouch 0.2 meters, right? So now I did not ask you anything. I asked you when I was in the air, right, at location C, that was the max height. What was the net force acting on me? And that is very easy. If I ask you to draw a free body diagram at this location, because when you do a vertical jump, right, at the max height, what you are in free fall, when you are in free fall, anytime you jump up, when you are off the ground, a 70-kilogram man off the ground, what would be the net force acting on him? That's very easy. At that location, a free body diagram would be, since he is in free fall, Fg is equal to mg, and that is Fg is equal to 70 times 10. So this is 700 Newton. Of course, this should be negative because the net force, the direction of the net force is to the down, and that is problem 10. A 4 Newton block is sitting right now. This is the friction diagram. This is force of friction. This is the time. This is 1. This is 0.9, right? You apply some force, right? That applied force accelerate the object. So object is moving. Okay, if the object is moving, what is a friction, the coefficient of friction, coefficient of kinetic friction. So this is F over Fn. So who is FF? You're gonna, since it is moving, you're gonna use 0.9. 0.9 divided by 4, right? This is Fn. Fn is 4 Newton. G is 4 Newton, because the mass is 4 Newton divided by G, which is 10. So the mass is 0.4, right? If you don't like 4 Newton, you can write 0.4 kilogram, if that makes you feel better. So this is 0.23. There is no SI unit. 12, problem 12, you have a car, 1200 kilogram car is on the road. That is the car has wheels. Okay, and this is the dry asphalt, and that it has mu s 0.85, mu k 0.67. Since the car is moving, right, accelerating, I ask you to find the acceleration of the car. First, you have to find the force. How many forces acting on it? Okay, so first you hit the brake, right? If you hit the brake, what happened? The wheels slow down because of friction. So what type of friction? The kinetic friction. So mu k Fn. So the velocity is getting smaller and smaller and eventually 0, right? I'm going to make this one bigger. I'm going to make this one smaller, and I'm going to make it 0. Okay. So this is velocity vector. So what happened? Why? Because acceleration is this way. Because the net force is this way. So you're going to find the net force. So net force is actually Fk. All right. So how much is that? 0.67 times 12,000. So this is 12,000, right? 1200, 12,000. So this is 0.67. This is 8,000. 8,000 watt Newton. So acceleration is f net over m. So f net is 8,000 over m is 1200. 0, 0, 0, 0 cancel. So this is 6.7. 6.7 at what direction? 6.7 at this direction. Negative. Oh, I'm not going to write negative because it's already pointed this direction, meter per second square. Net force is also this direction. Okay. Velocity is this direction, acceleration is direction, net force is this direction. So this car will have velocity over here 0. This car will stop. Next time probably I will ask how long does it take for this car to stop. This is Earth. This is ISS. How much? Distance is 400 kilometers. And since Earth is also round, we prove that from here to here is 637,000 meters. And from here to here is, I did not draw it to this scale, sorry, 400,000 meters. Okay, so you know that Fg is equal to Fg, mg is equal to g small m big M over r squared. So g on the ISS we are trying to find big G big M over r squared. So what is r? R is 637,000. So this is 400,000. So 0.0000776. So from center of the Earth to the ISS is 677,000 meters. So you're gonna write G is equal to 6.67 times 10 raised to negative 11 Newton meter square over kilogram square. Mass 6 times 10 raised to 24 kilogram, and this is 677,000 meter square, and that is 6.67 times 6 divided by 6. 77 square is 4.6 times 10 raised to 13, and this is times 10 raised to negative 11, positive 24. So this is 6.67 times 6 divided by 4.6, 8.7 times 10 raised to negative 11, positive 24, negative 13. So G is equal to 8.7 meter per second square, because 24 minus 24 is 0. Okay, what is the 8.7 meter per second square? So ISS, some of you think that the gravity acceleration due to gravity is 0. No, it's almost 9.8. 14, 15, 16, the sound was missing. Oh, I have to do it again. Very bad luck today. It's happening again and again and again. So 14, this is the graph. So for first 2 seconds, I cover 4 meters. Then next 1 second, I'm at rest. Next 1 second, I'm speeding up, covering 4 meters. And next 1 second, I'm back to right here at 4 meters, covering additional 4 meters. So that's our DT graph, and now our VT graph is going to be very easy. So I'm going to just do it in 3 regions. 4 divided by 2, so velocity is 2. I'm going to use the green color. The velocity slope of this one is 0, so velocity is 0 2 to 3 seconds. The 3 to 4 second object is speeding up, but at 4 seconds it is obvious that velocity is 0. So at 4 second velocity is 0. At 3 second velocity must be maximum. So why is that? Because area is half BH. So area from 3 to 4 second, it covered 8 minus 4, 4 minus 3. So velocity is 8. So here the velocity is 8. So from 8, velocity is 8 to 7 to all the way to 0. Okay, great. Since this is symmetric, if the velocity, if the acceleration over here is negative 8, acceleration over here is negative 8, acceleration over here is also negative 8. the acceleration is same over here. The velocity is 8 over here, so negative 8 over here. So velocity is negative 8, negative 8. So this must be a straight line because the acceleration over here is the same. What is that acceleration? Acceleration is negative 8. How is that? Because VF, acceleration is VF minus VI over delta t. So VF is negative 8 minus VI is 8 over 5 minus 3. Acceleration is negative 8. So if we draw the acceleration versus time graph, acceleration from 0 to 2 second, 0. Acceleration from 2 to 3 second, 0. Acceleration from 3 to 5 second, negative 8. Okay, now we're gonna do problem number 15 and 16. 15, y is equal to mx plus b. This point is 4 comma 0. When the time is 4, velocity is 0. We are not using this graph, we are using this graph. So we're gonna call it vt, not pt. So this is not p of t, this is v of t. Okay, so y is negative 8, x is 4, plus b, we are trying to find b. Y is 0, so b is 32. So y is equal to mx plus b. So y is v of t minus 8t plus 32. Now I ask you to do it at 3.2. At 3.2, the velocity is, this is 3. So 3.2 velocity is positive because it's above the x. So 3.2 is equal to minus 8, 3.2 plus 32. So the velocity is 6.4 or something meter per second, but you check. 16, I asked you to find the velocity over here. So velocity over here is negative because this is below x-axis. So v of t is equal to negative 8t plus 32. So now 4.2 is equal to negative 8, 4.2 plus 32. So v of 4.2 is negative 1.6. I don't know. Double check. So that takes us to problem number 16. Problem number 16, I ask you if the earth, and there is an apple over here at 40 meters above the ground, and there is a moon over here some 3.8 times 10 raised to 11 meter above. Why the earth falling and hitting the why the apple falling and hitting the earth, but moon falling doesn't hit the earth? It's because the apple doesn't have any sideway velocity. The moon has sideway velocity. In fact, moon sideway velocity is 1 kilometer per second. Where does the moon sideway velocity come from? A Big Bang. During the Big Bang, it got its sideway velocity. Okay, sideway velocity has another name. Okay, think about sun, and this is Earth. Okay, and the distance is 15 million kilometers. So this is the Earth tangential velocity or sideway velocity, and this is we're just gonna call this is centripetal force. The Earth sideway velocity, centripetal force come from gravity. Earth sideway velocity is about 30 kilometer per second, I believe. Not sure 100%. Okay, where does the sideway velocity come from? Sideway velocity come from during the Big Bang. So, and also, from the solar system during the Big Bang. Without the sideway velocity, the Earth would be falling and the Earth would be falling and hitting the sun. because of the side wave velocity, Earth is falling to the sun but doesn't hit the sun. Apple doesn't have side wave velocity, so it's falling the Earth and hitting the Earth. The moon has side wave velocity, so moon is falling the Earth but doesn't hit the Earth. Okay, here that's it. Okay, next problem. Rope 1, mass rope 2. If you pull the rope with this is mass 300 gram. If you pull, the rope has the limit, breaking limit is 7 Newton. If you pull the rope with 6 FP, negative 6 Newton down, then it's pending forever. Which rope will break? So you're going to do rope 1, mass, and rope 2. So let's first do rope 2. Let's start with rope 2. Rope 2 would be easier. So this is F pole, negative 6 Newton. So this is FT is negative positive 6 Newton. This is FG is 3 Newton, and F pole is 6 Newton. So 6 plus 3, 9 Newton. FT is 9 Newton. So this is F down, okay, due to mass, 9 Newton. So this is F ceiling, 9 Newton. It cannot handle 9 Newton because the limit is 7 Newton. So this is this breaks. Because 9 Newton is bigger than 7 Newton. So this rope 1 breaks. Rope 2 doesn't break because 6 Newton, number 1, 6 Newton is less than the breaking limit, 7 Newton. Also, it's a long time. It takes long time. The rope can send the information from rope 2 to rope mass to rope 1. Okay, great. That takes us to next problem. Problem number 19. Recording this is for the second time. The first time I did it on Friday, but there was no sound. For some reason, the sound was missing from the tutorial, so I had to do it today on Sunday. And I was sick all day yesterday. I wasn't able to do it. I'm so sorry. Problem number 19. So so this is 60 meter. This is 110 meter. At what velocity? What Vy is always 0 when you jump off of the rooftop, height h. Then Vy is always 0. What should be the Vx? So you don't land at 100, or you don't land at 120. You land exactly at 110. Okay, you exactly land at 110. What would be the Vx? Okay, very easy. So Dx is equal to Vixt. That's it. So Vx has to be dx over t. It seemed like I only need the t. I don't need dx. I know dx. Okay, so this is dy is equal to Viyt plus half a yt square, and this is 0 because it's given. Dy is 60. This is 5t squared. So t is equal to square root of 12. So t is equal to 3.5. So this is 3.32 meters per second. So the last problem is number 20. I cannot believe I'm solving last problem. And I'm not sure whether the sound is this time is good. So 3 building. This is 40 meter building. This is 200 meter building. This is 380 building. This is you throw something with 90 degree at 30 meter per second, you drop it and you do something, I don't care, as long as you because it's given the three ball, you see three ball falling, right? Both fall, all three ball falling almost the same time. If all three ball falling almost same time, you're gonna find the easiest one, and easiest one is this one. Why is that? Because this is drop. So what are you going to do? D is equal to VIT plus half AT squared. So this is 0. Why this is 0? Initial velocity when you drop something is 0. So this is 200 5t squared, because acceleration is g, which is negative 10. So t squared is equal to 440. So t is equal to 6. If it was 49, then is 7. If it is 36, then 6. So 6 point something, 6 point, let's say 3 seconds. Okay, so yeah, they all are the same. Okay, so it has not been a fun experience, but anyway, I did it.